Somera Muddiirolyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe, science laboratory ssaako ne computer lab.
Balamusiza mwenna abalabi ba Babasa nembebaza okwekuumiranga ku Babasa buli kaseera konna. Mwasiibye mutya nno basebo ne bannyabo. Our candidates, good afternoon. You are welcome to yet another program of Somera Muddiirolyo. Teacher Warugaba Sajjad, and today it is chemistry, inorganic chemistry. Those who have been with us, we have been on iron and its compounds. And last time, I left you with the question, a simple question, to describe the reactions of iron with air and then with water. That question, in our previous lessons, we covered very extensively the reactions of iron with the air and with the water. Sorry, with the acids. It is reactions of iron with the acids and with water. So, for those who are tempted, thank you. But remember, the answers are direct from what we have been. Actually, we covered it, I think, last week. The answers are very direct from what we studied last week. However, let me point out to this, how you are supposed to answer. With air, remember the other time we said iron does not react with dry air. So your answer would start by saying iron does not react with dry air in the cold. But when it is heated, it reacts to form triiron tetraoxide. Then you write the equation. The equation we wrote it last time. I don't need to repeat it. Then you go, we also said it reacts with moist air to form hydrated iron 3 oxide. That is rust. You also write the equation for how that rust is formed. We also discussed it last time. Then with the acids, remember we said iron reacts with the acids, with the dilute acids to form hydrogen gas and plus the iron 2 salts. So you write the equation. Even last time we wrote that equation. It is there directed. Then you go to, remember we also said nitric acid gives a mixed reaction. You also mention it. Then you go to concentrated sulfuric acid. That is where it produces iron 3 sulfate and the sulfur dioxide. Then you also write the what? You write the equation. And that one you will have covered. Let me once again thank those who tried. You see, these questions are meant to help you not to forget. When a question comes, you go back and see. If you can do it without going back, well and good. But if you get some obstacle somewhere, then you can go back a bit and check and see what you are supposed to write. Now, let us continue now with you remember we last time we were on compounds of iron in oxidation state plus 3. We completed those compounds of iron in oxidation state plus 2. We were on oxidation of compounds of iron in oxidation state plus 3. And the last time was hydrogen 3 oxide, if you remember. Hydrogen 3 hydrogen 3 hydroxide. We talked about how it is prepared, and we said you add sodium hydroxide solution or ammonia solution to a salt of iron 3, then you will get the reddish brown solid, that is iron 3 hydroxide. Most of you, I know that you have all done those experiments in form for testing for iron 3, and you know its test, adding sodium hydroxide and adding ammonia solution. Now, that was the third. Now, the fourth is iron 3 chloride. Iron 3 chloride is where we are starting from. Iron 3 chloride. Iron 3 chloride is another compound of iron in oxidation state plus 3. Now, you know, I have always told you that when you get the theory, when you know the theory, the practicals will become very easy. When you know the theory, the practicals become very easy. Now, we have two types of iron 3 chloride. There is anhydrous, if it is like this. The one which is anhydrous is black. We can say that anhydrous iron 3 chloride is black. That is the one which does not have water of crystallization. It is black. And it is prepared by heating iron in a stream of chlorine. It is prepared by heating iron in a stream of chlorine. And the equation is plus chlorine, then it gives you iron 3 chloride. Remember, when you write these chemical equations, you must always balance them. You must always balance them. I think it balances like that. So this anhydrous iron 3 chloride is a black solid. It is a black solid, and you can prepare it like that. Now, this iron 3 chloride, it exists like this in the solid form. But in the vapor form, it demineralizes. In the vapor form, it demineralizes. The iron 3 chloride, it forms a dimer. It demineralizes in vapor phase. In the vapor phase. What does that one mean? It means two molecules of iron 3 chloride come together. In the vapor phase, it demineralizes, and it demineralizes in the vapor phase to form the formula would be like this. Would be like this. This one is a dimer. It contains two molecules of iron 3 chloride. So they come together to form a dimer. That is in the vapor phase. So when you calculate the relative molecular mass, sometimes they can give you a question, calculate the relative molecular mass. You will find that the relative molecular mass you get is corresponding to this formula. That one now is a dimer, and of this, one which would be like this. like this. This is its structure. That is how it exists in the vapor phase. That is the hydrated iron 3 chloride. Now, that compound is deliquescent, first of all. It is deliquescent. You know, I hope you know the meaning of deliquescent. It absorbs moisture. It is deliquescent. And when it absorbs moisture, it forms the brownish. It forms that the brownish yellow hydrate. That is the deliquescent one. I mean the one which is hydrated. It is deliquescent, and the hydrated one, the hydrated iron 3 chloride, the hydrated iron 3 chloride, like this, is brownish yellow. That is the hydrated one. Is brownish yellow. So in most cases, the one you will see in the lab will be brownish yellow because it is hydrated. As I told you, the one which is anhydrous is black, but it is deliquescent. So when it absorbs moisture, then it forms the hydrated form. Then it looks brownish yellow. That is the one which is hydrated, the brownish yellow solid. And when it dissolves in water, it forms a yellow solution. When you dissolve that iron 3 chloride in water, it forms a yellow solution. The hydrated iron 3 chloride is, this is the formula, is brownish yellow, forming a yellow solution. Forming a yellow solution in water. Forming a yellow solution in water. So if you are carrying out those practicals, and in most cases when you see a yellow solution, you have dissolved a salt which was a brownish yellow, then it forms a yellow solution. Then it should click in your mind that that solution may be containing the hydrated, I mean that solution must be containing iron 3 ions. And that yellow color is due to, the yellow color is due to this. So if they ask you, like iron 3 chloride was dissolved in water, then they say, write the formula of the ion responsible for that yellow color. This is the ion that is responsible. So when the iron 3 chloride dissolves in water, it forms a yellow solution containing this ion. So iron 3 ions exist in water as hydrated ions of this formula. And that one is yellow. In fact, most of the solutions of iron 3 in water are yellow. They are yellow solutions. Now, this ion is considerably hydrolyzed in water. This ion is hydrolyzed. I hope you have studied hydrolysis in physical chemistry. The ion is hydrolyzed in water to form an acidic solution. So when you put iron 3 chloride in water and you put litmus paper, the blue litmus paper will turn red. Sometimes they ask you, state what is observed when you put litmus paper in a solution of iron 3 chloride in water. You'd say the blue litmus paper turns red. Then they ask you, explain your observation. When they say explain your observation, then you will say that hydrated ions are hydrolyzed by water to form the oxonium ions, which make the solution acidic. Then you write the equation. So, since this ion is hydrolyzed in water, the equation you would need would be like this. Plus water, because it is hydrolyzed by water. Then you get this complex plus so these are hydrated hydrogen ions. They are the ones responsible for the acidic nature of solutions of ion 3 in water. It is this, the oxonium ions, or hydrated hydrogen ions. They are the ones responsible for making solutions of ion 3 in water to be acidic. So we'd say ion 3 chloride is hydrolyzed in water to form the oxonium ions, which make the solution acidic. Then you write the equation. I know that if you have not yet studied hydrolysis in physical chemistry, you will reach hydrolysis, and again you will meet this. You will meet that equation again. Now, I have already told you that solutions of ion 3 in water are yellow. Solutions of ion 3 in water are yellow. Now, I hope that one has been taken. Now, that one marks the end of compounds of ion in oxidation state plus 3. Now, our next one, want to look at how do you convert, if you have been given ion 2, how do you change it to ion 3? Sometimes in the practicals it will come and then they ask you, they give you a solution, they say add sodium hydroxide. You add sodium hydroxide, then you get a green precipitate, getting a green precipitate insoluble in excess, then you deduct that ion 2 ions suspected, then they tell you add add ammonia solution. Again, you see a reddish brown precipitate insoluble in excess. You see a green precipitate insoluble in excess. Then you deduct ion 2 ions suspected present. Then the next step they tell you add, say, concentrated nitric acid and maybe warm. Then after warming, they divide the resultant solution into 2 portions. Then they tell you to the first portion add sodium hydroxide solution dropwise until in excess. You do what you did at the beginning, but in this solution after you have added concentrated nitric acid. Divide the solution into 2 portions. To the first portion add sodium hydroxide solution dropwise until in excess. Then you see a reddish brown precipitate. If you remember, we said ion 3 hydroxide is reddish brown. So when you see the reddish brown precipitate, then you, of course, you deduct ion 3 ions present. But remember at the beginning you were saying ion 2 ions present. So your theory should tell you now that At the beginning, you were dealing with ion 2. Then when you added concentrated nitric acid, you oxidized the ion 2 to ion 3. Then when they tell you to add sodium hydroxide now, you are testing for ion 3. So you will not get the same results that you got at the beginning. This time it will be reddish brown precipitate. Of course, you will say ion 3 ions present. But then you have to say ion 2 was oxidized to ion 3. So we want to look at those reagents which, when you add to ion 2, you get ion 3. So that when you are carrying out an analysis, you know that if I add this, I expect this one to do this. Or I expect this change. So that is the interconversion of ion 2 to ion 3. That is the one now we want to look at. We want to look at ion 2 to ion 3 interconversion. Ion 3 to ion 2 to ion 3 interconversion. How do you convert ion 2 to ion 3? How do you convert ion 2 to ion 3? Now, the first one is with concentrated nitric acid. And that is the common reaction they tell you during practicals. With concentrated nitric acid on heating. With concentrated nitric acid on heating. The solution, of course, will turn from, you expect, even now I think you can even guess, the solution turns from green. Remember, the ion 2 ions are green in solution. From green to yellow. And brown fumes are evolved. Brown fumes are evolved. Always remember those observations. Whenever concentrated nitric acid is used, concentrated nitric acid is an oxidizing agent. And whenever concentrated nitric acid oxidizes, it produces the brown fumes. Whenever you see add concentrated nitric acid and heat, you should know that concentrated nitric acid is an oxidizing agent. And whenever it oxidizes, it forms the brown fumes. Those brown fumes are of nitrogen dioxide. The brown fumes are of nitrogen dioxide. Then the half equations. You can be expected to write half equations. Ion 2, if it changes to ion 3, that is the first half equation. The first half equation. Then you will get plus water. Here too, I think then here 3. Isn't it? Now, when you write the half equations, if you know the half equation, then it becomes very easy for you to write the overall. You can write the overall equation. So these are the half equations. Now, when you write the half equation, you add them, then you get the overall. Now, overall, that is, if we add this one to this one, we get the overall equation. The overall, we add this to this. Remember, when we add this, we make sure that you eliminate the electrons. So here we have 1 electron, but here we have 3, which means the whole of this equation, we multiply it by 3 so that we can get here 3, which we move out with these ones. That is the trick. So you write the overall equation as, and always remember that when you write these ionic equations, remember also to balance the charges. Don't balance the atoms only. You must also balance the charges. Then it gives you plus water. So that is how the concentrated nitric acid will react with a solution containing ion 3 ions. Now, although here I have given you the half equations, in the examination, if they have not asked for the halves, don't give the halves. I'm giving you halves because sometimes they first ask you, write the half equations. Then after asking you that one, then they say, write the overall equation. But for God's sake, if they have not asked for the half equations, don't write them. Just write the equation they want. Because if you write the half equations, you will get it wrong. Actually, they will mark these ones wrong and they will think you have written many, you want them to choose which ones. So please, if they have not asked for the halves, don't write them. If they ask them, well and good, if you know them. And you can tell from this one that the solution, this one now which is green, is changing to yellow. Then it forms nitrogen monoxide gas. Now, remember in our observation we said that brown fumes are also given. But here we have written nitrogen monoxide, which is a colorless gas. But you have to know that, you have to know this one, that nitrogen monoxide is oxidized. Is oxidized to this. That's why you cannot have this one, because the moment this gas comes into contact with the air, automatically it becomes this one. So for you, when you are heating, although in the reaction this one is coming out, but the moment it is in contact with oxygen, it forms the brown fumes. You get those brown fumes. Alternatively, if you want to write the equation where you get the brown fumes, you can also write that one where you get the brown fumes, like plus, this is now the half equation, plus, then it will give you plus I hope it is balancing. Is it? Now, this one I think it needs to be. So, when you write like this, you get now directly the what? The the brown fumes. You can also write it like this. Then when you write the half equation like this, then the overall, I have already written the half equation for the ion 2 to ion 3. So the overall now, if you have decided to use this one, then overall will be, still you add the NO plus the ion 2 plus the acid, then you will get NO2 plus ion 3 plus water. So there are two equations. You can write this one, still it is admissible, or you can write this one, this equation. Either you write this one or you write this one. That is, if they ask you for, if you want to write this one, then the half equation you will write will be this one. In case they wanted the half equation. So please, you must note that one. Now, B is with bromine water. With bromine water or chlorine water. With bromine So when you use concentrated nitric acid, you are able to change ion 2 to ion 3, as you can see, ion 2 to ion 3. What about if we use bromine water? What about using bromine water? The bromine water changes also. The bromine water changes from reddish brown, to colorless. From reddish brown to colorless. That is the bromine water. Then the half equation for bromine. For ion, this one we are just repeating what you have already written. It is this. Those are the two half equations in case they ask for the half equations. Then, of course, for the overall, you add them. Overall, we add this and this with the aim of eliminating what? Electrons. So this one is 2 electrons, this one is 1, which means we multiply the whole of this equation by 2 so that the 2 electrons here will go with these ones. Okay? So they ask you the overall, write the equation, then you write this. Don't write the half if they have not asked you to write the halves. Remember, this one is green, this one is yellow. This one is green, this one is yellow. So the observations now will depend on what you want to say. That's why, for me here, I said the bromine water, I mentioned the bromine water changes from reddish brown to colorless. But another student may say, since this one is reddish brown, you can say this is the green one. The green solution of ion changes to yellow. That's why I am mentioning this one so that the examiner knows that you have seen the bromine water, which was reddish brown, has changed to colorless. If you want, you can mention the ion to ion solution changes from green to yellow. So there you mention which reagent you mean. Now, and this one would be the overall. That would be the overall equation. Of course, chlorine also reacts in the same way. If it was chlorine, it would be in the same way. And then C, with hydrogen peroxide. Hydrogen peroxide is also common in labs, with hydrogen peroxide. With hydrogen peroxide. The half equation B that is, if you use hydrogen peroxide, then you balance 2 here and also here too. Then the half equation for iron is already there. The half equation for iron, now you are familiar with it, is already there. That is the half equation for iron. For hydrogen peroxide, this is the half equation. Please you have to note these half equations. They are very, very important. Most of you, even now, most of you did not know the half equation for hydrogen peroxide. But this is the half equation. And then the overall, of course, as before, we add the two halves. These are the halves. Then overall, hydrogen peroxide plus acidified plus. Now, this one we have 2. Here there is 2. So we multiply this by 2, and this one by 2. So that's how it balances. Then it gives you plus even 2. Please always check for the balancing. I may make a mistake, but always check for the balancing. I hope it is balancing. Now, for hydrogen peroxide, I know now you can tell the observation. If they asked you acidified hydrogen peroxide was added to a solution of ion to ions, state what was observed. State what was observed. So all these others are colorless, except this one is green, this one is yellow. So you would just say the green solution turns yellow. The green solution turns yellow. So once again, the hydrogen peroxide has been able to oxidize ion 2 ions to ion 3 ions. That was with hydrogen peroxide. Now, acidified potassium permanganate, even this one is common to your titrations. Acidified potassium manganate 7. Acidified potassium manganate 7. You know that potassium permanganate is an oxidizing agent. So And we know that when the potassium manganate 7 oxidizes, its purple color changes to colorless. Then you write the half equation, if you can. The half equation, this is the what? The permanganate. It gives you manganate ions, manganate 2 ions, plus water. This one is 4. Again, I think, do we need to write this one again? This one is very common in titrations. Those equations in titrations, they are very, 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 very common. In fact, the titration of potassium permanganate with the ion 2 ions, it is also very common. So this is the halves for this equation. Then the overall you add. Here we have 5 electrons. Here we have 1. So multiply the whole of this one by 5 with the aim of having here 5, which will go out with that one. So, and sometimes if you know the equation, you can, from that equation, you can also get the observations if you know the equations. In organic chemistry is almost about equations, and maybe that is the reason most students hate it. Most students hate inorganic chemistry because of these equations. Now, from this overall, you can also now get to know the what? You can get the observations that the potassium permanganate, which is, this one is purple. The purple solution turns colorless. The purple solution of potassium permanganate changes to colorless. That one you are familiar with also. So this one is the overall. The observation, purple solution of potassium permanganate turns colorless. It turns colorless. But once again, you can see that the ion 2 has been oxidized to ion 3 according to that equation. And lastly, with potassium dichromate, with acidified potassium dichromate solution. With acidified potassium dichromate solution. What? Even sometimes potassium dichromate, they carry out titration. It can be used to titrate and estimate the amount of ion. So the orange color turns green. Potassium dichromate is orange in color. But when it reacts, when it oxidizes ion 2, it changes to green or dark green. And the half equation now. Today's lesson has been of equations and equations. Equations. Now, the half equation for the dichromate plus, it has to be acidified, then it gives you chromium plus water and then is it balancing? Are the charges balancing? Are the charges balancing? This is the half equation for the dichromate. It is also very, very, very important. You have to know it. Just like the other one of permanganate. Of course, the one for iron now, it is a common thing for all of them. Then you add those equations. When you add, here we need to multiply this one by 6. So overall now, you get plus 6 plus water. And the solution we changes from orange to dark green. From orange to dark green. And that is, so once again you have also oxidized iron 2 to iron 3. Now, before we complete our lesson, the time is almost over. I want you to write the question very fast. Hope it takes like 3 minutes. This the question, which will keep you somehow busy. You say, when a pale green solid P, write very fast, when a pale green solid P, when a pale green solid P was heated strongly, it decomposed to give a gas which turned red litmus paper, which turned blue litmus paper red. Which turned blue litmus paper red. Which turned blue litmus paper red, and a red solid Q. And a red solid and a red solid Q. Q dissolved in dilute nitric acid Q dissolved in dilute nitric acid to give solution R. To give solution R. To give solution R. R reacted with sodium hydroxide. R reacted with sodium hydroxide solution. to give a reddish brown solid. Brown. To give a reddish brown solid. S. To give a reddish brown solid. S. S dissolved in dilute nitric acid in dilute nitric acid to form a yellow solution. Form a yellow solution. Now question A. Identify one P, Q, and S. Roman 2, solution R. Solution R. B. Write equation for the reaction between. Write equation for the reaction between write equation for the reaction between one Q and nitric acid. Two R and sodium hydroxide. Sodium hydroxide solution. And lastly, S and dilute nitric acid. S and dilute nitric acid. Please, candidates, try to do these questions. They help you master. They help you to recall very easily. Because when you read through your notes so far, you can get all these answers. So they are meant to help, to encourage you to read, to keep reading your notes. Don't relax, keep reading your notes. Next time, we shall start from there. Let me take this opportunity to thank you who have been following, those people who have been tuning in Babasa. I want to thank those technicians who are behind there, but you don't see them. Thank you very much.
Somera Muddiirolyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe, science laboratory, ssaako ne computer lab.